About 6.6. All right, so I've got some of these frames built up. I've actually built up several of them and flown them around. And so these frames are prototypes sent over by C++. These are, so they call them the Rapid Evolution. Kind of unique frames in that they're printed, and they are printed in various different filaments of what's out there in terms of like kind of nylon and carbon fiber glass blends, and some custom blending that C++ did as well. Unfortunately, my initial experience with these frames is not that great, mainly because of dealing with oscillation issues. So I started out, so these are 1S frames, but I started out with a 2S build, mainly because I wanted to get black box data. So this flywheel board has the black box built in, and I've got a pretty good sense of what what this build looks like on 2mm and 2.5, 3mm carbon fiber frames. And so I wanted to kind of stress test it a little bit. And this is in general a noisy build. And so it's a little bit unfair because these props are not very well balanced. The motors are pretty old at this point in time. And when I tried to fly this one, it didn't go super well and ended up having some flyaways. Where's the frame? So basically had kind of like to the moon sort of flyaways, and before I had even a chance to really dial things back, I did end up cracking the frame. I don't think this is truly fair. This is 2S, it's pushing it too far. But what I thought was interesting about this was where it broke. So when in the first video I did, one of the things I kind of thought was going to be an issue with the frame, just kind of looking over it, is you got this very stiff center section, so you got a ton of stiffness in here, which is good. But then the transition from the center area of stiffness to kind of this relatively straight and tapering arm is pretty fast, and so I kind of figured that there'd be a stress riser there. The other one too is that this arm doesn't flare back out at the motor mount. You can see that it kind of tapers in and just keeps tapering in until you get to the motor mount, and so I thought that that would be the other place that is a stress riser. And somehow in one crash I managed to demonstrate both of those concerns. It's kind of impressive that I could do this in one crash, but you can see right there it broke right where it comes in, where I was kind of expecting that there'd be some issues there. And then right there at the motor mount, I think what happened is when I crashed this, I think this side probably came down and actually hit the ground here and broke that. And I think that there was enough weight from the motor here to kind of go ahead and break that off. This might have been due to more than one crash because I did crash this a couple times trying to get it up in the air. So not really fair, but it's kind of nice when you do have things fail, is that you can learn from the failures. And even though this was pushed past where it was designed, this is 2S build, and also I was coming in basically just trying to keep it out of a neighbor's yard. So as this thing went to the moon, what I was doing was rolling it over and disarming so that, but still, it's a pretty harsh kind of fall out of the sky. So it's not really fair to say that this is weak, but I think it gives us some information about where this design can be optimized a little bit in terms of creating a little bit more gradual taper, both near the motor mount and near the frame, so that when you do come in and crash, that the force is distributed over the full arm rather than concentrated into stress risers there and there. I've only broken one of them, so I'm not sure if this is going to hold up with other frames, but that was kind of like, fit with my impression of looking at the frames. So I did have more success in terms of being able to get the quad to fly on a 1S build. So this is, I took my usual Warpig 1S build and just transferred it over onto this frame. And I did build it up with, this is not my usual style, but with these style frames, you got to throw that kind of whip canopy up top. And so when I used my filters and PIDs, I would still get flyaway. It wasn't like a shoot to the moon flyaway, but it was kind of this slow, like if instead of hovering and falling, being able to fall out of the air, it just kind of gradually comes up. So you can kind of fly it if you stay pitched forward or kind of rolling, things like that. And you can kind of get out of the oscillation temporarily by doing like a throttle pump and cut to kind of disrupt the oscillation or quick twitches or something like that. But overall, on my PID and filter, this was ultimately a flyaway. I was able to get it to fly by detuning it. So I brought the filters back to Betaflight defaults with RPM, and then I have to pull back on the master slider. So on my usual tune, I've got it set up with the master slider at 1.55, and also the P and D are kind of pushed up as well. So 1.55 isn't kind of like an absolute thing, but for the relative difference of showing what I had to do is I took this from 1.55 on the master slider and brought this down to 0.9 and was able to get it to fly reasonably well. Now, once we make that big of a change going from 1.55 down to 0.9, the quad does not fly as well. It just doesn't have as much, it's not as locked in, there's more bobbles. And in spite of doing that, this quad was still heating up the board. So one of the interesting things I learned about this is I've never been able to smoke a 1S motor. So I've done just total flyaway kind of like situations and just kind of never smoked a motor. And so I was curious how, just being a good test pilot, I just wanted to see how far I could take this. So before I detuned it, I went and just tried to fly as long as I could on my PIDs and filters and to see what would happen. And actually, no, it wasn't even on my PIDs and filters. It was on Betaflight default filters and my PIDs. And with those settings, what I flew it to was until the motors actually desoldered. That was a new one for me. So apparently I was pushing enough heat to where the failure point, which is a good failure point if anything, but the motor actually desoldered. I've never had that happen before. That was kind of interesting. But so I was just flying it around, and so as I said, it's kind of like it's in a chronic state of oscillation and flyaway. So to keep it from flying away, you have to kind of roll it over and bring it back down and catch it and stuff. So it's kind of an interesting kind of flight to keep it up in the air. But yeah, that's the way it failed, is the motor desoldered, and it desoldered, and I thought I had a desync, because what happened ultimately, the way the quad came down, is it went into what seemed like a desync, where it just kind of went into a snap roll and just kept rolling. And when I picked up the quad, it was actually 2 out of 3 motor wires on one of the things had fully desoldered, and then one was just kind of left barely hanging on. And so that was kind of interesting. The other thing I've noticed on this, so I did fly this all SC Plus for his a diff all, his dump, so that I could try his settings. And on his settings, I was kind of in that chronic state of oscillation, chronic flyaway. Again, not to the moon, it's not shooting off to the moon, but it's just chronically oscillating. So going to defaults on the filters and then pulling the tune back. So to give you the perspective of the PID, that means that normally on my Warp Pig, I'm flying with a P at a 110 and a D at 70. And on this quad, I brought the P down to 60 and the D at 40. So same ratio, just brought it all down. And so even with that, this quad is not entirely happy, and I think it's still kind of like doing some kind of low-level oscillation, because what's interesting is when I fly this is that the temperature on the board comes up. So it was a little bit warm out yesterday when I was flying, but on the regular Warpig build, the temperature warning on the board did not come up at all, versus on this one, the temperature warning would come up, and I'd have to kind of to bring the temperature back down, I have to do some intentional kind of forward flight to get a lot of airflow going over it. Which is an interesting thing I learned. I think a lot of times what we do is on 2 to 3S builds, it's like we check our motor temps and we look at our motors to see, are the motors getting hot, and that's our sign of too much D or not enough filtering and things like that. What this has possibly taught me, and I'm not sure, maybe it's unique to this board or this combination, these motors or something, but these motors, even when this thing desoldered, the motors came down, they weren't hot, which I don't fully understand, but maybe it's just the low voltage or whatever it is. The motors just aren't getting hot, but the board is heating up. So I think one of the things we need to think about doing is when we're looking at, okay, am I having too much noise, too much D, is instead of checking the motor temps, what we should probably actually do is put the board temperature up on the OSD, and so you can watch that temperature and see if it's kind of like drifting up versus a more conservative tune and filter. But so that's what I have so far. So in terms of the flight stuff, aside from the first frame break, I didn't break any others, but at the same time, I didn't really fly them that hard because the quad's just not flying that well. I think ultimately for me, this frame doesn't have enough rigidity to control the noise well enough to get it tuned to the place where I think it flies well. So in all fairness, this frame does achieve something, performance-wise. This build is, so on the printed framed Rapid Evolution, this frame is about a gram lighter than my carbon fiber frame on the Warpig. But really and truly, when we're talking about a 60 gram all-up weight, I personally don't think that 1 gram of weight savings is really going to translate into enough of a performance difference to offset what I'm having to do to detune the quad. So I think there's plenty of room to add a gram, even 2 grams of weight to this frame and really increase the rigidity. So in terms of the rigidity, let's see if I can show you. The thing where I think where the issue is coming in, if I put just a little, I'm not putting a whole lot of pressure, but if I just put a little pressure on this, I think you can kind of see how much this just twists. And so I think that's where the oscillation is coming from. So, that's the amount of motion that we can get into the frame without really a whole lot of, I'll try and put that same amount of force. So this is going to twist too, but I'm trying to put in about the same amount of force. And, this one, it's clearly softer. And it's a different sort of softness. It's a little gummier where as you get off center, it doesn't, so carbon fiber, what it does, the spring rate ramps up. So if you talk about how stiff something is, you can talk about kind of the spring stiffness. With carbon fiber, kind of in the middle, there's a little wiggle, but as soon as you start to really deflect it, it gets more rigid very rapidly. So as I go this way, I have to put more and more force to really kind of get it to twist. What I'm noticing with these printed frames is that it's more elastic, where maybe it doesn't feel all that crazy, how it's pretty soft. But as I come out here, I can keep just twisting it, and without really adding, this ramp up of force, I can really twist it and displace it quite a bit. The one challenge there, I think, though, is if you make this a lot stiffer, I think it is going to be more prone to break potentially, because some of your crash resistance comes from the flexibility of the frame. But I think at the end of the day, one of the tough parts when you're thinking about frames is, C+ kind of mentioned that their target was getting something on par with the baby tooth 1.5 millimeter frame, and I think they achieved that in terms of the weight and durability of that. But when you're designing for just not yourself, you have to kind of if that's the goal. So if the goal is to just design for yourself, do whatever you want. Don't listen to anybody because there's not a reason to. On the other hand, if you're intending for other people to use things, you just got to kind of anticipate that people are going to take what you designed. People are going to take something that works for you, and then do all kinds of things that you never really anticipated people would do with the frame. They're gonna have just different perceptions of what a frame should be able to do or shouldn't do, and so when you're designing, you have to push robustness up as a priority. And that was one of the things I did with going to thicker and thicker frames on the Warpig, was pushing the robustness of this to where, with this frame in a 2.5 millimeter for the 120 millimeter frame, you can do really silly things in terms of bad props and tunes and things like that. And the frame can handle it. It's robust enough to where you're not going to get, I haven't seen maybe some people have, but I haven't seen the flyaway and the oscillation issues. If you're kind of on the edge, if you're on the borderline, something about my builds just aren't quite doing the same thing that C+ is doing, and I'm just having more problems with the oscillation, and that just happens. That's going to happen out there when you put frames out into the world. Part of that, you know, who knows? Maybe part of it is my board is more sensitive. So I'm flying. These are the old FPV cycle Tune RC original 1S boards. I think C+ is flying. He sent one of these over, which I still need to build up and test. I'm really interested to test it. So this is the Darwin FPV board. And this one's kind of fun because it's got the built-in Express LRS. There's the little UFL to pop antenna on there. And this is like a 1 to 2, I think maybe 1 to 3S board. And maybe this one will work better. I don't know. But that's what happens is when you put frames out into the real world, people are going to throw it on all kinds of different builds and have different perception of what's a clean enough motor, what's, you know, like these props aren't brand new. So can I clean this build up and is it going to fly better? Sure. But I find that this level of beat up prop is something I fly on regularly. I find that this level of motor kind of beat upness is something I fly on regularly, and so I expect if I grab a frame and build it up, you know, it should work. And unfortunately, this one doesn't. But the good news is, I think there's enough room there on the weight to where you can really improve the rigidity of this frame and still get it to where what I think is a competitive weight. So those are my thoughts. I hope that these thoughts are coming across as constructive. I really like a lot of what's going on with this frame. I think it's really exciting that people are pushing the boundaries of what can be done with printing, because I would absolutely love to just be able to print out, you know, a whole bunch of prototypes and test them rather than having to, you know, send stuff off and get it cut and things like that. And so, you know, if people can get this printing stuff sorted to where it's competitive with carbon fiber, I'm all for it. So although right now this frame isn't quite working for me, I'm excited about the potential that it might down the road. Okay, till next time, cheers.